In this first section of the lesson, we're going to explore interactions between maps and texts. Let's start with the problem of dealing with ambiguous place names. Now, one of the challenges of natural languages is that a particular expression may often have more than one meaning. We know, for example, that in the TV show The Simpsons, it takes place in the United States in a city called Springfield, but one of the running jokes in the show is that we never know which state Springfield is in because there are so many of them in the United States. One command that we have is called semantic interpretation, which tries to assign the most probable meaning to a string, and it returns an entity as a result. So if we ask for the semantic interpretation of each of these three phrases, Big Apple, City of Light, City of Brotherly Love, Mathematica knows that the first is New York City, the second is Paris, France, and the third is Philadelphia. If we ask Mathematica to make its best guess for Springfield, it returns Springfield, Massachusetts. So we say semantic interpretation of Springfield, put that in default Springfield. And default Springfield, if we ask for administrative division, i.e. what state is this Springfield in, it tells us Massachusetts. Now in this case, we'd like to know what other Springfields there are in the United States, and for this we're going to use something called ambiguity function. So we say semantic interpretation of Springfield, we set the ambiguity function to all, and we store the result in a list, and we'll see that this in fact gives us a long list of entities named Springfield. If we put this in table form and we map the input form command across this list, we can see that the first one is Massachusetts, the second one is Ohio, the third one is Illinois, and so on. Some of these forms, like these ones in Wisconsin, are hyphenated, so Springfield Marquette, Springfield St. Croix, and so on. And we also see that some of the Springfields it knows about are actually neighborhoods and not cities as such as one in Jacksonville, Florida, or one in Dayton, Ohio. We can use the cases command to pull out all the Springfields that are cities and not neighborhoods, that are in the United States, and that do not have hyphenated names. And that's what this next expression does here. We use the cases command, pulling out entity city where name is Springfield. This is the state that it's in, and as the single underscore matches the state, and then United States. And if we do the input form on those, we can now see that we have just the list of the Springfields that we might want to plot on a map. Now once you have a list of entities like this, it's quite easy to plot them. We just use the command geolistplot, and that gives us this map of all of the Springfields in the United States. And as you can see, there are quite a lot of them, most of them on the eastern portion of the continent. Now another task that we might want to do as part of our research process is to go through a text and extract place names and then plot those on a map. So it might be useful in some cases to plot locations that we find in texts. In this next example, what I've done is I've used the Wikipedia data command to get the article on Silicon Valley. And then I've created a list of cities in that article by using the text cases command. Remember that text cases is very high level, and it lets us do very interesting things with the meanings of texts and with the understanding texts. What we're asking for is we're asking for cities, and this cities arrow interpretation says, don't just tell us which things are cities, but return the Mathematica entity that corresponds to that city. And you can see that in this select command, I'm using a pure function that says that the head of the item should be an entity. And we get a list of cities, and if you're familiar with California, you know that the first ones are in California. Now we can check the interpretation of those entities to make sure that they're correct cities. So one thing we want to do is we want to go through and we want to find all of the cities in this list, all of the places in this list that are not cities in California. So we're using the complement command to subtract out cities that have California, United States, and find out what's left after we do that. And we can see that once we go through and we use that command, we have a city in Michigan, Oslo, Norway, a city in Cuba, and Zurich in Switzerland. Now, in fact, Santa Clara is misidentified. It should be a city in California, not the one in Cuba. And in previous versions of this process, the code also identified a number of places in Oklahoma and Georgia and so on. The only one of those that remains, is this one, Marysville, Michigan. But we can rewrite that one so that it means Marysville, California. We can rewrite the interpretation of Santa Clara in Cuba so it's Santa Clara in California. Now, the reason that this expression is different now than it was when I wrote it is because Mathematica is continually under development. So the text contents command changes its power, its ability, its likeliness of getting confused on a regular basis, which means that if you write code at one point and then run it again later, it might change. So that's something that happens when you're developing your own code, is you have to go back sometimes and see what's changed and make adjustments. In this particular case, I didn't adjust that to remove, say, Menlo, Georgia, so that rule is still there even though we no longer need it. Once we have this list that says that the entity Marysville, Michigan should actually be the entity Marysville, California, we can use the shorthand form of this command, replace all, to transform our previous list and make these requested changes. And once we've done that, we can count how many times each of these cities is represented or mentioned in this Wikipedia article. So San Jose, right in the center of Silicon Valley, 24 times. Santa Clara, right next to San Jose, 4 times, and so on. Again, once we have a list, we can plot it. In this case, what we're doing is we have a list, actually we have an association that links each city to the number of times that it's mentioned, and that means we can use a command called GeoBubbleChart to plot that information where the size of the bubble reflects the size of this number here. So San Jose with 24 mentions is going to have the largest bubble. And as you can see, almost all of these mentions are centered right in the location of Silicon Valley in California. If we focus in on the state of California, we can set the padding to provide 100 miles around the place where we have most of the cities. And now we can see we have a nice map of California where almost all of these mentions of cities are focused right in Silicon Valley and a few in other places in California. Now there's one more example we can look at, and that is an example from the Mathematica documentation. It's quite nice. It shows how to discover and visualize the density of people who believe in particular religions in a given region of the world. So Mathematica has computable data about world religions, and for each religion it has things like the names of adherents, child religions, countries, date-founded, major texts. The child religions property gives us a link to branches of major religions. So if we take Islam, we find that there are 5 branches here, and we can use a command to ask how many people in this particular religion are part of that branch. And so it gives us an association where it gives us the branch of the religion and then the number of people who follow it. In this case, what the example does is it allows us to plot the density of people who are members of Shiite Islam versus the number of people who are members of Sunni Islam in these various countries, the former kind of centered in the Middle East and the latter more broadly spread throughout the Middle East and North Africa and Central Asia. We can also request entities, information about texts that are important in major religions. So here's our list of major religions as understood in the form of Mathematica entities. And if we have a particular religion, I just chose Lutheranism here as an example. If we have a particular religion, we can ask for major texts, and it gives us entities for each of those texts. Each one of these is a book entity. We can request a data set, and in this particular case, we have publication date, title, the Latin title, the original language, the author, Martin Luther.